Hello, and welcome to Controllers Tech. Some of you asked me to cover the TouchGFX for the cheaper displays, which uses the SPI. So before continuing the TouchGFX series, I decided to make a video about interfacing these cheaper SPI displays. This video will cover how to interface the ILI9341 based SPI display with STM32, and of course we will be using the TouchGFX. I am going to use the Kyle IDE in the tutorial, as the project wasn't working with Cube IDE. It needs a lot of fixes with Cube IDE, and I will do that later. This is back of the display I am using. Here you can see, we have the pins for the display, and these pins are for the touch. These are the libraries that we will be using in this tutorial. I have here the library for the ILI9341 driver. You can use any other display also, but you should find a working library for your display driver. The only requirement is that it should have a function to draw bitmap, and a function to set window. Most of the drivers do have these functions, so it's not a problem. More importantly, the driver must use the DMA for the big transfers. If the driver you are using satisfies this criteria, you can go ahead with the video. By the way, I am using the instructions provided in this article. I will leave this link in the description, do check it out. I can't explain the reasons for the steps that we will be using, otherwise the video will be very long. So read this article to understand the steps that I am going to show in this video. It's explained perfectly here. So let's continue, and open the Cube MX. Like I mentioned, this project won't work with Cube IDE just yet, so I will be using Kyle IDE today. I am using STM32F411 Discovery board. Let's clear these pins. Now first of all we will set the clock. I am using the external crystal for the clock. The crystal on this board is 8 MHz, and I want to run the system at maximum 100 MHz. Now go to the SPI, and enable the full duplex mode. I am using the SPI 1 because this driver is doing so. The baud rate is set at 25 megabits, and this is the maximum for this board. Go to NVIC, and enable the SPI interrupt. We need to also add the DMA, so add the DMA to transmit. Direction will be from memory to peripheral. Mode is normal, and check the use FIFO. We have the 3 pins now, the MOSI, MISO, and the clock pins. We still need to set up the CS, reset, and DC pins. Also this driver uses the names like reset, SPI1NSS, and DC. So I am going to name the pins in the similar way. All the 3 pins need to be set as output pins. That's it about the pins configuration. Next is the TouchGFX itself. Click on Software Packs, select Components. Here you can see the TouchGFX. You might need to install it for the first time, just click the Install button in front of it. Not all the boards support TouchGFX, so if you see this option grayed out, means your board does not support it. Select the TouchGFX and click OK. Here it is showing in the software pack. Enable the graphic application. We need to enable the CRC also.
Alright, the interface is custom,
pixel format is RGB565. The display width is 320, and height is 240 pixels. Since this MCU don't have too much RAM available, we will use the partial frame buffer. If you want to read more about this, read the original article. This is it for the TouchGFX part. At last we will configure a timer. The timer's purpose will be to call the sync signal, to sync the display. I am using the timer 2 for this, which is connected to the APB1 clock. You can read the datasheet to check the timer's connectivity. Right now the timer is running at 100 MHz, and we need to bring it down to certain frequency. It is clearly mentioned in the article, about how much frequency you should use. Anyway, I will try to explain this. So my SPI1 clock is at 25 megabits per second, means it can transfer 25 million bits in 1 second. The display size is 320 by 240. The RGB565 takes 2 bytes per pixel, and that's why multiplying by 2. The total size of the buffer needed in RAM is 15 kilobytes. If we convert this to bits, this is what we get. Dividing it by the SPI speed, I got around 50 milliseconds. This is the time the SPI will take to transfer 1 frame buffer. So the refresh time must be slower than this. And I got around 20 Hz, that is 20 frames per second. So now we need to bring the timer clock down to 20 Hz, so that we can call the display sync at this rate. So 100 MHz is the current frequency, and using a prescaler of 100 will bring it down to 1 MHz. Now the auto reload value of 50,000 would further reduce this clock to 20 Hz. Make sure you enable the timer interrupt. This is it, let's generate the code now. As I mentioned, this doesn't seems to be working in Cube IDE for now, and this is why I am using the Kyle IDE. Let's open the project folder. First of all, we will copy the library files. I am copying the display drivers into the core folder. Now go to the TouchGFX, target, and copy these data transfer files here. Alright, this is done. Now we will design the application. So open the TouchGFX file. Here we don't have any option to select any examples, so we will go with the blank UI. It want to reload the project, click yes. Now you can design the GUI as per your requirement. For the demonstration purpose, I am just adding a gauge. This will not display any value for now, as I just want to display something on the TFT. We can check the simulation to see how it will look. It seems fine, so generate the code. Now open the Kyle IDE. First of all, we will add the files into our project. I will include the touch library later. We need to do the same in the target folder. Add the data transfer files. Now in the main file, include the display library. Initialize the display. The rest will be taken care by this TouchGFX process function. Let's build it once to see the errors. We got one error. These are basically the instructions to make this project work. These are already taken care of in the data transfer files that we added to this project. So we will just comment them out. So we have no errors now. I forgot to include the timer for the sync operation. Start the time base in the interrupt mode. Now after 50 milliseconds, an interrupt will be triggered, and in the callback function, we will call the sync operation. Looks like this function is already defined here. Let me check the cube MX again. Here it is using the timer 11 for time base, and that explains the callback function. You can use the SysTick for the time base, but I will leave it like this. And instead, I am putting the sync code inside the callback here. I will leave this function here, commented out, in case you want to refer it. Alright, let's build the code, and download it to the board. Here you can see we got the image as we designed in the TouchGFX. So the drivers and the TouchGFX, all are working fine. Now we will add the touch control to this. The display have separate pins for it, you can see here. Basically we need to set up another SPI for the touch control. This display uses the XPT2046 touch driver. Here is the source file for the driver. Notice here that the pins are named at TIRQ and TCS. Also it uses SPI2, so I am also going to use the same. Keep the baud rate around 5 megabits. Enable the interrupt. We don't need to set up the DMA for this one. 3 pins are set for the SPI, now we need to set the remaining 2. The interrupt pin, set it as the external interrupt. I am going to name it TIRQ, just how it's named in the driver. And at last the TCS pins as output. Now we need to configure the external interrupt. Set the trigger as the falling edge, and pull the pin high. Also enable the NVIC for the external interrupt. Everything is set, so generate the code. Reload the Kyle, so that new changes can be included. We will come back to this, but first we need to modify the TouchGFX project we created. I am going to add buttons here, to show the touch interface. So we have Flex Button 1, and Flex Button 2. Now we will add the interactions to these buttons. So when the Flex Button 2 is clicked, it will hide the gauge widget. And similarly, when the Flex Button 1 is clicked, it will show the gauge widget. Let's try this in the simulator first. Things seems to be working all right. Generate the code now. Kyle is asking for reload, so click yes. The next thing we need to do is add the touch library files to the project. So we have added the source and header files for the touch, and now include it in the main. In the main function, initialize the XPT. Now comes this last file, the touchcontroller.cpp. We already have the same file in our project, so we will only copy few necessary things into it. So first copy these entire things, including the include section. Now we will modify the sample touch function. So if you are using any other driver, make sure it have the functions like update, which basically updates the touch coordinates, and a function like isReasonable to check the coordinates are valid or not. Instead of isReasonable, you can also use some calibration function, whatever is defined in the library. If you check the data transfer file that we copied earlier, the transmit block function uses the two functions from the display driver: the set window function, and the draw bitmap function. Like I mentioned in the beginning, these are the only functions you need for the display driver to work. Here we have some problem with the vsync. After the code was regenerated, it removed the definition of the vsync. Let me put it back again. Alright, let's build the code, and flash it to the board. So everything is working great so far. The touch is responding well, and there is not much delay in the animations too. The limitations of using TouchGFX in such cases is clearly the memories. The controller I am using does not have enough RAM or flash memory to be able to handle larger projects. But if the controller have the support for QSPI and FMC, you can use the SD-RAM and external flash memories to overcome these limitations. This is it for this video. You can continue watching the TouchGFX series, and try to implement those projects in these low-cost LCDs. If the size is not the problem, the project will definitely work. You can read more about the functions we used, the files we copied, and the reason behind everything we did, in the article I showed in the beginning. The link to the post is in the description. You can download the project from the description too. I will try to make this work with Cube IDE also, and if it succeeds, I will make a quick video about it too. That's all for today. Leave comments in case of any doubt. Keep watching, and have a nice day ahead.